The plant breeder I'll be talking about is Barbara McClintock. For Barbara's early life and education, she was born on June 16, 1902 in Hartford, Connecticut, as one of 4 siblings in her family. Barbara attended Cornell's College of Agriculture in 1919, and she earned her bachelor's in 1923, her master's in 1925, and her PhD in botany in 1927. One of her professors, C.B. Hutchinson, invited her to take graduate genetics in 1922, and was ultimately what steered her passion towards genetics and following a career. For Barbara's professional career, she worked at Cornell as a researcher and botany professor, the University of Missouri as an assistant professor of botany, where she studied X-rays and their effects on chromosomes and plant cells, Cold Spring Harbor, where she worked as a laboratory researcher where she discovered transposition, and the Carnegie Institution, where she also worked as a researcher. Barbara McClintock had several scientific contributions. She developed carmine staining techniques, which allowed her to visualize maize chromosomes, and was the first to show the morphology of 10 different maize chromosomes. She was the first person to describe the interaction of homologous chromosomes during meiosis, and proved chromosomal crossover during meiosis. She published the first genetic map of maize in 1931, and was the first to describe the function of both the centromere and telomeres. She was also the first to prove genes were physically located on chromosomes, and the first to show that chromosomes cross over during meiosis and were not static on the gene. She had several more contributions, which, while working with X-rays, discovered ring chromosomes in maize plants. She showed that the loss of ring chromosomes at meiosis caused variegation in the offspring of maize plants damaged by radiation. She discovered activators and dissociation during research on the coloration of maize seed and named them controlling elements. This led to the discovery that both could change position on the chromosome. She was credited with the discovery of transposition and hypothesized that gene regulation and how organisms with identical genomes have cells with different functions. Barbara, however, faced many career struggles that followed her throughout her time at the University of Missouri and at the Cold Harbor Institute. At the University of Missouri, Barbara believed that she was being held back in her career and felt she was subject to the university's retaliation after Lewis Stadler's departure. Her publications also received harsh criticism, as her hypothesis and findings challenged current scientific beliefs, ultimately leading her to stop publishing her work in 1953. As she discovered transposition, it was widely believed that genes were static and fixed on their location of the chromosome. It wasn't until the 1970s when a French researcher rediscovered her work, and she was finally given credit for her discoveries. Barbara McClintock received a plethora of awards and achievements throughout her lifetime, starting in 1947 with the Achievement Award from the American Association of University Women. In 1959, she was elected Fellow of the American Academy of Arts and Sciences, and in 1967, she was awarded the Kimber Genetics Award. In 1970, she was the first woman to win the National Medal of Science by Richard Nixon, and in 1973, the Cold Spring Harbor Institute named a building dedicated to her and her work. In 1978, she received the Lewis and Burt Friedman Foundation Award and the Lewis S. Rosenthal Award. And in 1981, she was the first recipient of the MacArthur Foundation Grant, the Albert Lasker Award for Basic Medical Research, the Wolf Prize in Medicine, the Thomas Hunt Morgan Medal by the Genetic Society of America. In 1982, she was awarded the Louisa Gross Horowitz Prize, and in 1986, she was inducted into the Women's Hall of Fame. In 1989, she was a foreign member of the Royal Society, and in 1993, she was awarded the Benjamin Franklin Medal for Distinguished Achievement in the Sciences of the American Philosophical Society. Her most notable award, however, was Barbara McClintock's Nobel Prize that she was awarded for Physiology and Medicine in 1983. She received the award for discovering mobile genetic elements and by examining the changes in maize. She was the first American woman to win the Nobel Prize, and she was the first woman to win an unshared Nobel Prize. Most of Barbara's awards came after the rediscovery of her work in the 1970s, as she was shunned by the scientific community until the rediscovery happened.